Thank you for the homework. Let's look at number 9. This is what Tifo sent through. Number 9A. Tifo got 1 and -4. Do you agree with him or not?
I agree.
Agree.
I agree.
Anyone who disagrees? No disagreement. Thank you, everybody. Thank you, Tifo. Number B. Tifo got -12 and 8. Anyone who disagrees with this answer?
No.
No what?
I don't disagree.
Oh,
I agree with the answer.
everybody disagrees. Thank you. Now let's go to number C, 9C. Tifo got -15 and -15. Huh? What? Yeah. Number C. Oh. He got 38 and 28.
Agree.
Agreed. Thank you. Now we are going to number 9D. Tifo got 4 and 29.
Agreed.
Agree.
Agree.
I got a different answer, sir.
Yo.
Who's talking? Who got a different answer?
Patricia, sir.
Patricia. But what is happening? How? What did you get, my sister?
For 90, I got -2 and 7.
Yo. Tifo? Oh, okay.
Yes,
okay.
sir.
Before we bring you in, is that Patricia who is talking?
Yes, sir.
Okay, my sister. You said you got?
-2 and 7.
Okay. Members, let's please all pay attention as I'm now requesting Patricia to share with us how she started and then arrived at that answer. Please interrupt her in the process of her explanation where she made a mistake. Patricia,
Yes, sir.
the stage is yours. Please dance.
Okay. And question 9D was requesting us to find 3v 3 times vector v -2 into vector u plus 2 into vector w. Am I correct?
You are right, ma'am.
Okay. And then I said 3 into vector v, which is 0.5. Then I got vector v, 3 times vector v, which is 0.15. Am I correct?
Correct, ma'am.
Minus 2 times vector u, which is -8 minus 2, or -8 plus 2 actually.
-8 plus what?
2W.
Plus 2.
Is that for vector u? U.
Yes, for vector u.
You saying?
8,
Oh, you know what Patricia did?
yes.
I think I see what you did. So you distributed the 2 into the u, which then means that you're going to have to distribute the 2 into the 2w afterwards.
Yes, yes.
Oh, okay.
So please tell us, what did you get for 2u?
For 2u, I got minus into 8 plus 2. Whoa.
To you. If you
I
distribute it.
see. Oh, I see my mistake here.
Okay.
I see my mistake. Yes. I shouldn't have added. I added instead.
Okay, Fix. We are with you. Fix until you tell us that you tell us what you get at the end. Fix. We are with you.
Okay, so I get minus 14 and 7. Am I correct?
For which
Minus
one, ma'am?
47.
For I've done the whole calculation now. For 90, I'm getting minus 14 and 7.
Mm-mm.
It's supposed to be 4.
Patricia,
Yes.
can I give you
Remember?
a bit of advice?
Yes.
When you solve these kind of questions, always follow BODMAS. Because
Yeah.
when you follow BODMAS, it helps you keep your arithmetic clean. Because now the problem is based on how you did it. So instead of actually solving the u plus 2w bracket first, then distributing the 2, you chose to distribute the -2 into the u, which works. But now the problem is it becomes messy because you're only going to have to end up distributing the -2 into 2w as well. Do you see? So now you're
Yes, I
multiplying
see.
over and over and over. Whereas if you did it via BODMAS, it might take a bit longer, but it's always easy to follow it's always easier to follow your methodology, and it's easier to find your mistakes when you make them, and it keeps your work cleaner.
All right. I hear what you are saying, which
Yeah.
means maybe I'll have to
So
start afresh.
yeah, so avoid working from left to right, which is what we are all inclined to do, but rather you do it piecemeal via BODMAS, and then you can always follow it easier that way.
Okay. Yeah, I understand. Thank you very much.
No
I
problem.
think, yes. Thank you.
Sir,
Hello.
when you don't do this in the BODMAS way and you still get the correct answer, is that wrong?
No?
Yeah. Tricky one for me to Lerato. Yeah, my brother. I must just thank God for me to have survived up to this month.
No, Lerato, I think what you are asking, if you show all the steps up until the final answer, you will be safe. The unsafe thing to do is to maybe use a different method. Anyway, there are always different methods when you are doing such algebra questions. But the important thing here is to show all the steps.
Okay, so sir, I want to ask you a question. This one is simple.
Okay.
Like when you do these questions, the way I'm looking at the first work, it's like I'm the only one who does direct substitution for each component, for each unit vector, and then at the end I mix it up. Because like T4 gets the answer, the one that I got, but like it's just one wiki. While in my case, I do, if it's a 4-unit vector, I do 4 workings.
Lerato, you're not the only one. I do it the same way as you, where I literally do all the steps.
I also do the same way, right?
Yeah. So I mean, if your arithmetic is strong, then you can clearly do what our gentleman here did, which is great. But if you know that you tend to make arithmetic errors like I do and you do, we will usually be inclined to do it step by step, so that if we do make a mistake, it's easy to go back and see exactly what happened. So it's fine.
Oh, no problem.
Yeah.
My advice is that please do it piecemeal. And then do it piecemeal and then put those pieces together according to the question. And then you will see how then they need to be worked out. The reason I'm saying that is because now you can make those mistakes and then we can be able to advise each other. In the exam, there'll be no time to look at to rectify what you have actually wrote. It will only be determined by the marks, your examination marks, which will be very late. Are we together?
Yes.
sir.
Yes, sir.
But am I making sense when I'm saying do it piecemeal, and then from there, take those pieces, put it in the equation that the original equation that you are solving.
I agree.
Do you all follow what I'm saying?
We
Yes.
follow you,
Yes,
sir.
sir.
Perfect
Yes, sir.
sense.
Thank you. Now I'm not going anywhere. Lerato, now my task is very easy. Don't worry. My task is very easy. Now I'm going to Patricia. Let me go and check whether there is Patricia's work here.
Oh yeah. It makes sense.
Wow. Wow. Wow.
Yeah. There is, do you all, can you all see my screen?
Yes.
Do you see all these people here?
Yes.
Whose work is this? Oh, yeah, this is Patricia's work. How did I forget to name it accordingly? Patricia, now we are going to your number 10A. Okay.
Yes, sir.
Sure.
My screen say is a problem.
Yeah. I know my handwriting is very bad, but hey, this one. Okay. For number 10A, Patricia got, let's
Mhm.
expand. Is it clear to everybody? 10A.
It's
Yes.
better.
It's
Yes, we can see now.
It's better. Not clear, but it's better.
Okay, it's better. I agree. All right, my brother. Thanks. For number 10A, Patricia got -2, 1, and -4. Do you agree or disagree with her?
disagree.
Agree.
Agree.
I agree.
Agree.
Anyone who disagrees?
Lerato.
No. Oh, Lerato. Oh, okay.
I got
Well,
positive.
you got +2.
Yes.
How?
I say I did a lot of mental maths. So
Aye, boy, you did the thing again.
eh,
The one we speak about every day. Well.
Every day. Yes, you.
Did we not
Thank
tell
you
you to
for
stop
saying
this mental math thing of yours?
4 minus 6. It's -2. It's not 2, man. Yeah.
Ah,
I was in
Lerato, Theo said it well to say it is what we advise you about every day. Huh.
Let's continue.
Okay, Lerato, now you made my life simple now. Number 11, I'm going to you. Don't worry.
Yeah.
For number B, 10B, Patricia got -10, 6, and -4. Anyone who
agree.
disagrees with her?
I agree.
I agree.
Agree, sir.
Agree.
Thank you, everybody. Now let's go to 10C. For 10C, Patricia got -60, -8, and -8.
That's final answer.
Mhm. That's according to, that's not me. That's Patricia.
I disagree.
I disagree.
I
Disagree too.
disagree.
Same.
Patricia.
Yes, sir.
Patricia.
Yes,
They
sir.
disagree with you.
Eh,
What happened?
May they please rectify me, sir?
Okay, let me not say anything. Patricia, all of them are disagreeing with you. Ne? Just pick any two people that you will prefer to advise you in terms of the mistake that you made. Pick any two people. Yeah, pick any.
Okay, I'd like to ask Lerato and Wendy.
Okay. Lerato, Wendy, please dance for us. Patricia is watching.
Like I said, you must do like direct substitution into this thing. V is -3 minus 8 times W, which is 6. -3 minus -3 times -3 minus 8 times 6. That will give you 132. That's how I did it. I don't know about the others. And then the second one, where it was -3 this time, instead of V it's 4. I think V is 4. Yeah, it's 4. V is 4, and then -3 times in bracket becomes 0 minus 8 times -1, and then it gave me direct answer. So I don't know, like maybe people have special formulas. I just use direct substitution in my case.
I did it similar to you, where literally I worked out everything in the bracket, then I distributed the -3 last.
Let's try and maybe explain it in a different way.
Patricia,
Yes, Wendy.
-3 is
That's not.
multiplying everything that is in the bracket. And when I only multiply.
Yeah, I can.
Minus
Yeah, that's why I made it say. I see.
Yeah.
Thank you very much.
Are you sure, Patricia?
Yes, I'm sure.
But
So I can.
Oh, okay.
You and I have got many. We have got many big problems to solve, Patricia. Under this situation.
Hey, sir.
Now, okay. Now let's go and check how Patricia worked out number 10D. Okay. For 10D, Patricia has got -77, 10, and 30.
Close.
Anyone who disagrees
so
or
close,
agrees with it?
so close.
So close.
I disagree.
So
Very
close, but
close.
so far.
Please,
I disagree.
Disagree.
Yes, sir.
Yes.
It's close.
No, so close.
So
Because-
close, but there is a disagreement.
Yeah, it's like, you know, it's like when you're in Polokwane versus Tanin. You know, yes, you're not in Joburg anymore, but age.
Mm.
You know what's disheartening about this maths? The everything until the final answer is exactly the same.
That's why yesterday I kept on pleading with you not to get bored. You know, you can collect, you can gather the maximum marks from these sections unless you pay attention.
So, sir,
it's easy to make mistakes. Yes, brother.
I mean, you would know and Lerato will know, because after we've been in these workshops for basically the whole year, the one thing I've picked up about a lot of us is we know all the higher order stuff, but the problem is we tend to get the higher order stuff wrong because we lack the basics. So we all know how to, for example, I know this was a thing with calculus. We all know how to derive logarithmically and how to derive using Weierstrass substitution. But the problem is, even though the methodology is always right, the answer ends up being wrong because our arithmetic is broken, generally. So yeah, so we know what to do, but the simple pluses and minuses and additions and which order to do it is the thing that always trips us up. And it's the reason why, for the longest time, we've all had, in inverted commas, fought here in the workshop, where it's a write out all the steps, use your BODMAS, follow your order of operations, because, and it happens a lot. It's not just Patricia, it happens even to me. It happens to me, it happens to Patricia, it happens to Lerato. He knows. We struggle with this thing where basic arithmetic, it's like we don't think too much about it, and so we get it wrong a lot.
I agree with you, my brother. And it doesn't mean that we need to think hard about this. These are the basics. I agree with you. These are the basics that I think we learn from primary. And then we carried those basics to high school. It is those basics that we are still applying now. There is nothing new. Yeah.
We'll be fine.
Yeah, we'll be fine.
Okay, now, Patricia.
Yes, sir.
My sister, they disagree with you. Please ask them what they found. And then please ask any one of them to explain, to take us, you and I, because I also don't know these things. Don't worry. You are not the only one. I don't know these things. My boss just asked me to come to share these things with you. I don't know them. I don't know. Yes, I'm being honest. Please just ask anyone to explain it to us step by step. I'll also be learning, my sister.
Oh, okay, sir. Nogwazi, may you please explain to me how you got the right answer, please?
For the first step, I have 2 into -3, 1, 2, just bracket -7 into 6 -1 -4, just bracket -8 into 4, 0 -8, just bracket plus -3, 1 and 2. Then I multiply the -2 of the 2 and u. Then I have -6 and 2 and 4 minus 42 into 42 -7 -28 minus 8 into minus into 32 8 64 -64 plus open plus bracket plus -3
Please wait.
1 2.
Sorry,
Patricia,
sorry. Yes,
please stop where you don't follow. Ne? Wendy,
Yes.
please don't be fast. Please don't be fast so that we can be able to follow. Ne, Wendy?
it's Nogwazi, sir. So, Nogwazi,
Yes.
you
Oh,
said
it's not fast. Okay.
you got
Thank
a
you.
negative into 32, ne?
Yes.
Then what follows the 32? It's an 8 or a 0. How come it's an 8? Because 8 times 0 is 0.
8 times 8
Because you already multiplied 8 times 4, which is 32, I agree. Then the following component should be 8 times 0, which is 0.
Patricia,
Yes.
to make things easy, ne, do you see this 32 that you're talking about, right?
Yes, I see it, ma'am.
Is 32 0 minus 64, ne?
Yes.
On that part, you say 32 minus 3, and you got 29, right? 29,
minus,
that is 4. You say
yes,
32,
yes.
and you got
32 minus
29.
yes.
The second step, we are supposed to say 0 plus 1, and we're supposed to get 1, and when now you got -1, that's where you went wrong.
Oh, now I see.
And secondly, we were supposed to say -64 plus 2, we were supposed to get -62, and when now you got 62.
So close.
So
Oh,
close.
now I see.
So that's the only mistake that you did.
Okay, I see. Thank you.
Sharp.
And
Okay.
and your sorry, Patricia.
Yes, ma'am.
I also
Yes.
see that your 62 is positive, whereas it was supposed to be negative. And you see the bigger number is negative, which is 64. Negative
Yes.
64 plus 2. It's supposed to be negative
But
62.
isn't that, like the 64, like I multiplied it with that negative on the outer, like say negative times
But-
negative
but-
64, which is positive 64. Then plus.
But why didn't you do that with an
But why
29
the
and the
29
negative one?
is positive?
Yes.
I see, I made a mistake.
So like answer for C, 10C. What do you agree on?
So what's the final answer again, please?
Minus 77, 8, and 94.
I agree.
Thank you.
Agree.
And then
What is the answer for C?
132
C is
minus
132.
24
Mhm.
minus 24 minus 72.
I agree. For C.
C, 132 minus 24 minus 72. I agree.
Minus
What?
72. Minus 72.
Minus 72.
Minus 72, guys. I don't agree with that one.
It's minus 72, yes.
I got
Minus-
132 minus 24, 120.
Okay, same here, same here.
Okay.
Yo.
And Wendy, you see what you got?
Say, I got 132 minus 24 and minus 72
I got that too.
On number 10C.
on,
10C.
on number
yes.
C, yes.
10C. No, Wendy, this is your work. This is what
No,
you.
sir, that's
This is
Patricia's work.
Patricia.
Oh, sorry. Sorry. Patricia.
Yes, sir.
Oh, this is Patricia's work. Sorry. Patricia, we have got a long way to go, you and I. Eh?
Yeah, I can see, sir.
But
mean-
it is never late. Just
Oh.
have to pay for. Just
Well.
have to pay attention. Yes.
You know, when I was doing this work, I was
Mm.
tired. I was in a workshop. I was from a workshop, so my mind was kind of tired. But I know I can do this. You don't have to stress about me, sir.
Oh, I'm stressed. Oh, there's no way that I can. There's no way that I can be stressed.
But I mean, I can do this, sir. So
Huh?
simple multiplication. Just simple, like applying the Potter's rules. I kind of made mistakes somewhere here and there, but I see I can manage.
But I can see you can't manage. That's why I'm worried.
Sir. All right.
Trust the learner.
Eh, Raja?
Trust the learner. They say trust can build a nation.
Okay.
Something
All right.
like that. Say,
Okay. Yes.
on the final term for 10C, is it minus 48 or minus 72 or minus 120?
Minus
Okay.
72.
Minus 72.
Minus
Please
72.
confirm with others, Lerato.
They are saying minus 72,
And what do you have?
minus 48.
How
Minus?
did you arrive at that answer?
It's the head.
Yo. That head of yours. There is something wrong with that head of yours, my brother. Hi, Lerato.
Say, I realized something when I was doing this work. You remember that timetable that you have to know from 1 to 12, it's important in this module.
What?
True.
The table
What are you
of
saying? What did you
table of multiplication from 1 to 12, it's important in this module because
Okay.
yes.
Yeah. Now, for the last time, let's confirm the answer for number 10D.
10
77.
Positive 8, positive 94.
Thank you. Please repeat.
Minus 77, positive 8, positive 94.
Thank you. Can we step off number 10?
Yes.
Now we are going to Lerato in number 11.
Yeah.
You. Number 11. Yo. Yeah.
Ay, bo.
You're starting off sideways.
What's number 11? Completed in that page.
Okay. Here is number 11. Number 11A. Lerato has got -1, 9, -11, and 1. Is there anyone who disagrees with him?
We agree.
I agree.
Okay. Thank you, everybody. Thank you, Lerato. Now, number B. Lerato has got -13, 13, -36, and -2. Anyone who disagrees?
We agree.
I agree.
Agree.
Thank you. Number C. Lerato has got -15, -19, 10, and -6. Anyone who disagrees?
Multiplied by 6.
Multiply by 6, then you find.
The 6 is outside.
Okay. Yes,
Like
but
I
it's
did not.
Why did you put it outside?
yeah, but it's correct.
6 times 19.
Oh, yes.
It's correct.
Okay, thank you. Now, 11D.
So sorry, what is the final answer for 60? Do we leave it like that in factorized form?
No.
You mean
you
for
can
C? For C, that 6
Yes.
must come. That 6 must come inside.
from your
Or
head.
after it comes inside, what do we have as the final answer?
We have got what is 15 times 6?
90.
15,
Is
30.
90.
That's not 90. 19 times 6, what is it?
114.
Is 114.
Which will be negative. These first two terms will be negative, ne?
Yes, sir.
Yes.
Then
And the last
third one, then the third one will be 60. Do we agree?
Yes.
Yes.
The last one will be -36.
Yes, sir.
Okay. Yes, sir.
Thank you. Now let's go to D. In D, Lerato got -8.
No, sir. You're reading the wrong thing.
Okay. Okay. Sorry, Lerato. Sorry. In D, Lerato got 27, 29, -27, and 9. Anyone who agrees or
Agreed.
disagrees?
We agree, say.
Okay. Thank you. Now, let me go back here. Who should I go to?
See,
D4. Okay, thank you.
Oh, we did it already, sir.
You already did mine, so we'll go to the others.
say.
Okay, where should we go?
Go to
Thando.
Theo.
Where should I go?
Thando.
Theo.
Okay.
Ah, you want to see my arithmetic errors? Okay. I'm pretty sure I have them as well.
Okay, let's go to number. Is this 12, ne?
Yes, it is, sir.
Okay. Now,
Enough.
for 12A, Theo has got positive 7, positive 3, minus 5, minus 1, and positive 5. Is there anyone who disagrees?
Yes, sir.
Do you disagree?
Yes.
Yes. What did you get?
7,
I
5.
got. Yeah, I got the similar one with Lirato.
What
7,
is it?
5. 7, 5,
7,
negative.
5, minus 5.
7, 5, negative 5, negative 1.
Oh
And
yeah,
5.
yeah. Yes, it should be 5 because it must be 4. It must be 4 plus 1. Yes. I made a mistake there.
Brother, Theo,
Yes, sir.
please.
There
I'm
are two
begging
mis-
you. I'm begging you. Please collect maximum marks
Yes, sir.
from this section.
Mm-hmm.
Patricia,
Thanks for the correction, everybody.
Yes, sir.
Patricia,
Yes, sir.
please make yourself proud by getting maximum marks from all these sections that I've already covered.
Yes, sir.
Thanks.
Yes.
Now, let's go to see what Theo got for number 12B. Theo got 6, 0, minus 15, 27, and minus 6.
I disagree.
Anyone who disagrees?
I disagree, sir.
I
With the-
agree.
Agree?
I hear the disagreement. There is
Which
one.
means I'm wrong. Then I agree.
I disagree.
No. You don't have to. You don't have to agree with them if you disagree.
Lerato,
Sir,
I agree. Mina.
I agree.
I disagree.
Yes, my sister. I like that. What did you get?
6, 15, minus 15, 27, and minus 6.
Yeah. Now let's go to that second entry. How did you get that? You said 15, né?
Yes.
Yeah, we are interested in knowing how you got that 15. Please share that with us.
Say.
How? How? You disagreed so loudly, but you're oohing so quietly. Hi, boy. Teach us. Let's do it.
Ish. Say. Let me start from the beginning. Ne? I have 3 open brackets, 2 open brackets, 1, 2, minus 3, 5, and 0. Anger.
We are listening, my sister. Members, please, everybody, let's pay attention to what. Hey, who's talking?
Thando.
Okay, Nomtandazo. Members, please, let's pay attention to what Nomtandazo is saying. And then let's please help her where she starts to make a mistake. Nomtandazo, please go ahead, my sister.
I multiplied every element of U by 2, Anger, and I got 2, 4, minus 6, 10, 0.
Mm-hmm.
Then I subtracted with 0, 4, minus 1, 1, and 2.
Mm-hmm.
And I got 2. Oh, yes. Yeah, I've seen my mistake.
Continue. Yes, we continue. We are listening.
I got 2, 5, minus 5, 9, minus 2. And I was supposed to get 2, 0, minus 5, 9, and minus 2.
In order to get what?
In order to get 6, 0, minus 15, 27, and minus 6.
Then what will that give you?
6, 0, minus 15, 27, minus 6. The final answer, say.
What's your final answer now?
6, 0, minus 15, 27, minus 6.
My sister, you don't have to agree with them.
Yes.
Okay? Yes. Thank you everybody for having worked this exercise out. Thank you, Theo. Now, let's go and see what Theo got for number 12C. Theo got minus 27, minus 6, positive 14, positive 12, minus 14. Anyone who disagrees with this answer?
Lerato.
I agree, sir.
You agree?
Agree.
Yes.
I noted the
Agreed.
agreement.
Agreed.
Thank you. Lerado, you disagree.
Yes.
What
I
did you get?
disagree too.
Good.
You someone disagree? Hey, you must raise your voice. Don't do that. Disagree too. Hey, I disagree so that we can hear. Oh,
I disagree, sir, but it's
yes, be proud of your disagreement. Oh, who's talking? Who disagrees?
It's Wayne, it's Wayne.
Yes, Wendy. Thank you. Wendy and Lerado disagree. Yes, Wendy. Where do you disagree?
I got minus 27, minus 6, positive 9, 12, and minus 8.
Oh, those two entries. Yeah.
Yes.
Now, members, please let's ask Wendy to start from the beginning so that we can be able to trace where she made a mistake so that those two entries can be similar to what we got. Wendy, please start from the beginning.
Okay, I said 3 multiplied by vector u, which is vector u is 1, 2, minus 3, 5, and 0. And I subtracted vector v, which is 0, 4, minus 1, 2, 1, and 2. And then on the other side
Wendy,
of the bracket, yes,
can I ask for a small favor?
yes,
I think it'll help us follow easier. You know how you said you multiplied 3 with vector u?
yes.
It'd be okay with you after you say you multiplied 3 with vector u, give us that answer, then move on to the next one so that we can, I think we'll follow easier that way.
Yes.
Oh, okay.
Yes.
Cool. And when I multiply 3 with vector u, I got 3, 6, minus 9, 15, and 0.
Cool. Thank you.
Okay. And then on the other side of the bracket, I multiplied vector u with 2, which I got 2, 4, minus 6, 10, and 0.
Okay.
And then I multiplied vector w with 4, which I got 28, 4, minus 6, minus 8, and 6.
You said you got 24 and 28 and?
For which one? For
4W.
B.
4W.
Oh,
What's your 4W?
I got 28, 4,
Yes.
minus 16, minus 8, and 6.
6 isn't supposed to be 12.
Oh, I
There
see.
we go.
Okay. On the next step, when I multiply, when I work out the two vectors 3u minus v, I
Mhm.
get 3, 2, minus 13, 14, and minus 2.
Please say it again. You said you got
I
3, 2.
3, 2, minus 13.
Ah,
Okay,
see?
it's minus
Ah.
10. I see.
Whoa, look at it again.
It's
What's
3,
what's
2,
tell me something. What's minus 9 minus
Aibo.
minus 1?
It's minus 8. Okay, so now I have 3, 2, minus 8, 14, and minus 2.
Okay.
And then on the other side, I will have 30, 8, minus 22, 2, and 12.
Then we have the same answer.
Okay, thank you.
Thank you, my sister. Now, let's go to the last one, which is 12D from Theo.
This one looks wrong. This one just looks wrong. It just looks
Theo,
wrong.
who said that? We never said
Me.
that.
I said it looks wrong.
We never said that. For number D, this is what our brother got. He got 9 over 2. Minus 7 over 2. Minus 7 over 2. 5 over 2. Negative 3 over 2. Oh, let me expand so that we
Expand.
Zoom. Yes.
Yeah.
Whoa, okay. Who zoomed?
Yes. First entry is 9 over 2. The next one minus 7 over 2. The third minus 7 over 2. Positive 5 over 2. Yo, Theo, your minus looks like a comma.
Oh,
or a
sorry.
dot.
Oh,
Or
so
like
sorry.
a dot.
So sorry.
Okay. And then and minus 3 over 2. Members, do you agree with number 12D or not?
We agree, sir.
Impossible.
Disagree?
Ah,
Anyone disagree?
Yes, sir.
Someone said disagree?
Wow.
Who disagrees?
No was.
No quasi. Okay, thank you. Noted. Who else disagrees or agrees?
Sharon
Sharon agrees or disagrees?
disagrees.
No
Lerato
quasi. Legato?
agrees.
Nontandas agrees, sir.
Okay. Who else agrees? Who else disagrees? Sharon Nogwazi. Let's take Sharon first. Sharon,
Yes,
please
sir.
take us through step by step. Members, please listen attentively. Where there seems to be any discrepancies, please do come in. Sharon, then followed by Nogwazi.
Sir,
Yes.
if possible, can you please go to Sharon's work so that if she explains, we will be looking at what she wrote. It will be easier for us to see the mistake.
Or is Sharon and who? Nogwazi, ne?
Yes.
Yes, sir.
Sharon and Nogwazi. Now let's. Is there Nogwazi here? There is Sharon. There is Nogwazi. Whose work should I go to?
Nogwazi.
Nogwazi. Okay. Then we are going to 12. We are only seeing nails here.
What is going on?
Sharon, I mean, Nogwazi, what is happening here?
It's number
That
21.
was one page.
21, sir. 21 page.
Yeah.
Page 1 of 1.
Let's try sharing.
Or,
Sir.
or should we also count these nails as pages, my sister?
Yes, sir.
Yeah.
It's one page.
It's literally one page.
Yes, 1 page. You see, it says 1 of 1. But if you look at this page, she seems to have written even at the back, but we don't know what we are unable to see what is written at the back.
Like I think. Yes.
Yes, yes, yes.
Yes, sir.
Yes.
Like the pictures are there on the phone. They are waiting, but they did
The
not.
what?
The pictures of the whole work are on the phone. They did not come in the PDF.
On her phone.
Yes.
Yeah.
It's a
Do you see them?
I can't see them. Say. Yeah.
Okay, now let's go to Sharon. It is Nogwazi and Sharon who disagree. Ne? So now we are going. We tried Nogwazi, we didn't win. Now we are going to Sharon. That's 12D. Sharon,
Yes, sir.
I can see Sharon as the first name. What is this other one?
Oh, Nanaya.
Nanaya, and then
Noguto.
Jack.
Yes, sir.
Nice.
Hey,
Nice.
hey, you are handwriting, my sister. I have got a bad handwriting, but at least I can be able to compare. Okay, 12D. Okay, Sharon got 5/2 minus 15/2. 5/2. Yeah, Sharon,
Yes, sir.
did you scratch out this one?
Yes, sir.
Okay. Now is 5/2 minus 15/2, 5/2 minus 15/2 minus 3/2. Where is the discrepancy? With
Okay,
video?
I used BODMAS. So what he did, he subtracted was this W, like W minus 5V first, but I added 5V plus 2U.
You
Okay,
added 5.
Yobo.
You
I'm
added
looking.
5.
Yeah, 5. Is it V? Sorry, V
Yeah.
plus 2U. Yeah, I added
So-
it first.
So here's my thing. Oh, are you saying you added minus 5V plus 2U? Because that's
Yes.
how. Okay, so you didn't add 5V plus 2U, you added minus 5V plus 2U.
No.
No, I think she added
Only just
5V,
5V. Yeah.
not negative 5V.
And the problem is,
Yes.
if you see, the problem is by adding 5V and 2U and leaving the negative out, you're treating it like you've factored the negative out, and then it throws your arithmetic off. Because remember, the negative
Oh.
goes with the 5V and the plus goes with the 2U. So if you're gonna work with those two first, your equation is basically 2U minus 5V, or it's minus 5V plus 2U. You can't leave the negative out, because by leaving it out, what you're basically saying is you've got negative, and then brackets, you've got 5V minus 2U. Does that make sense?
Yeah.
Because when you distribute it in, then it's going to turn into a positive.
Okay. I see
There
my
you go.
mistake. Yeah. Silly mistakes.
Yeah, we all make them. A
Who
lot.
made a mistake this time? Is it you, Sharon?
Yes. I excluded the negative sign.
My sister.
Yes, sir.
Hey, you people. You see, now is windy. The rains will soon coming. Do you want me to be swept away by this stream that I'm sleeping next to?
No, sir.
I'm sleeping under the bridge. Next to where you are staying, Sharon. Not far from where you are staying.
You are safe, sir.
Am I?
Don't worry, you are warm.
You pass me. I'm one of those standing in one of the robots there. And then you just pass me as if you don't know me. Am I still safe when you pass me without recognizing me? Therefore,
Plenty are still coming, sir. Worry not.
oh, okay. Thank you. Now let me go back. And now, Sharon, who should I pick now? We are now going to number 17. Sharon, pick.
I pick myself, sir.
Who pick yourself? Yeah.
Yes, sir.
Okay. Now we are going to Sharon again, number 17. Sharon for number 17 got A to be 3 and B to be -1. Anyone who agrees or disagrees?
Yeah, I agree.
Agree.
I agree.
Agreed, sir.
Oh, beautiful work, Sharon.
Thank you, Theo.
I love your methodology. I love
Yeah,
how
your work is very neat, man.
yeah,
I
no,
love it.
and it's very easy to follow as well. Ah, this is beautiful.
Okay. Thank you, Sharon. Thank you, everybody.
But I have a question,
Eh,
say. Sorry.
Yes,
Ah,
we
I
are
wanna
listening.
know. Yes. Is this the only way to solve this thing?
No, actually, it isn't.
No, it's not, ma'am. No, it
So
isn't.
I can give you 3 ways off the top of my head. You
Yes.
could have, so you know how you could have had your system of equations, right? And then you could have used
Equation.
substitution. You could have used Gaussian elimination, and one which is very easy to actually do as well is you could have also used Cramer's rule.
I used none of that, but I got the same
Same answer,
So
yeah. So there's many ways, but the 3 I thought of when I was looking at it is Gaussian elimination, Cramer's rule, and direct substitution, basically.
okay.
Mhm.
Say,
Mhm.
I am asking, I am requesting that may you please view my work so that you guys can see what I did, because clearly, no.
Okay, okay. What you did, let me see again.
I sort of used a simultaneous equation type of thing. I don't
Yeah.
know.
This is what I
That's
see.
still correct, right?
Yeah, I understand what you did. Beautiful work. Bloody beautiful work.
We see what you did.
I can't see anything. Have you?
We don't have any. I don't have any problem.
Did you change?
No.
Because I'm still looking at
I'm still
the
looking at
previous thing
Sharon's
that we
work.
were looking at. I can still see Sharon's work too.
Yeah, I see it. Angiti, we are looking at number 17.
Yes, this is Sharon's work. Yes.
Yes.
Sharon, what is it that is bothering you?
It's
Say,
not
no, this is Wendy. Say.
Oh, yes.
Hey, whoa, hey, whoa, hey.
Maybe you did not get me. This is Wendy.
Whoa. Whose work is this? This is Sharon's work, ne?
Yes.
Thank you. Okay. Is there any other person who wants us to look at her work for number 17?
That's what I'm saying. As Wendy, I'm asking that may you please open my work so that you guys can see what I did and
now
maybe
I
direct
understand.
me.
Yes, Wendy. Now I understand. I was getting confused. Do you get me? I was confused.
Yes.
Yes. Thank you for clarifying that confusion.
Because I feel like it's by chance that I got the correct
Yeah,
answer.
by chance. Whoa. You are
What a
lucky.
lucky chance.
Were you crying as well?
Crying, sir.
Crying, yeah. Coloring. Coloring. I see these colors. Brown, green, white.
Oh,
Let's leave you.
no.
Let's leave you a coloring. Now let's go to number 7. This is, what number is this?
It's
Yeah,
17, sir.
17.
Is this 17?
Yes. You see what I
Uh,
did there, sir?
So
I
there's
don't know
no
if-
chance. She did it right. There's no chance. You did the right thing.
Oh, okay.
So you did that thing I
Thank
spoke about with the other work where I said you use system of equations and you substitute. This is what you did. Perfect.
A is 3.
Okay.
B is -1.
Thank you.
Answer for 17.
Yeah.
What is it?
A is 3 and B is -1.
I disagree.
Aye, boy.
Isn't it vice versa? B is 3, A is -1.
I got A is 3 and B
That
is
is for B, number B. But
Number 17 there.
Oh yes, number 17, A is 3, B is -1.
Thank you, sir. Whose work
How
is
should
this?
I know-
Whose
how
work
should I
is
know
this
that?
upside down
You-
work?
you-
Hey. So I can't read upside down, unfortunately. Sorry.
Yes. Okay. Uh-huh.
Oh.
B is
dear.
4.
Oh dear.
A is -4. B is A is -4, B is 4. Brother, how did you get these figures?
So it's, I think I swapped number 17 and 18 in the questions. Because if you can look at my number 18, I got what they got for number 17.
Oh.
What are
Yeah.
you saying, my king? Oh yeah.
Yeah, you swapped them. You just swapped the numbers.
Yeah,
Yeah.
he did so, sir.
Cow.
Lera, don't be creative, please. Hmm?
If I did this in exam, the marks are gone.
Yes.
They say, I'll be careful next time.
Sure. Okay. Since we are still on your page, on your paper here.
No, sir, don't go there.
Okay. Where should I go to?
You can go to T4 for number 19.
Because number 9.
17, 18. For 18, Dave.
Oh, I want number 19, say.
Now,
But it's
for 18, where should we go?
Nomthandazo.
Nomthandazo for number 18. Okay. Nomthandazo. Okay. You have got A to be -1 and B to be 3.
Yep.
I agree.
Agree.
Anyone disagrees?
Larat.
We have already seen your figures. What happened there?
I'm not sure.
Yeah, and as long as you are not sure, then we don't know where to help.
B should be 3. Because I had 2 equations, which were 2a minus 2b equals to -8. And the other one was a plus 3b equals to +8. And then I multiplied the second one by 2. Oh, I now understand, sir. I understand. 2 times 8, it's 16. It's not 24. On my case, I said 2a plus 6b equals 24. instead of equal 16.
Lerato?
Yeah.
Hey, yeah. You and Patricia.
Aye.
Hey, I'm worried about you too. Patricia,
Yes, sir.
you and Lerato. I'm worried about you. Okay, for number 19, where should we go? Tifo. I think you said we should go to you
Yes,
for
we-
number 19.
Yes, we may.
Okay. Yeah, I like this. See,
I'm sorry I didn't write them in order. I didn't want to go to the next page.
okay, I see. C1 is positive 37 over 23. Is there anyone who agrees or disagrees?
Tenders or disagrees?
Disagree?
Same here.
I disagree as well.
Yo,
Yeah,
yo,
but
yo. Yes, Banna. Nomtanders, what did you get, my sister, for C1?
2.
Me too.
Me too.
Same here.
Who is same here?
Sharon.
Yeah. Okay. Tifo,
Yes, sir.
brother,
Yes, sir.
please share with us how you arrived. at this
Okay, no
number.
problem. So I used the fact that if you are given, we know that equality of vectors, when vectors are equal, then their components are equal as well, right?
Yes.
So we were asked to find point scalar C1, C2, and C3. So please scroll up there, say, to where number 19 starts. So I started by multiplying the constants, the scalars, into the individual vectors on the left-hand side. So as you can see, the first step, I got C1, negative C1 and 0, plus 3C2, 2C2, C1, plus 0C3, 4C3 is equal to negative 1, 1, and 19. So did I make any mistake there, colleagues?
Members,
No.
No.
Okay.
please continue.
Then
Tifo.
still, all right. Therefore, on the next step again, I said, since the two vectors, they are equal, the left-hand side is equal to the right-hand side. It means the individual components must also be equal. So I said the first component, which is C1 plus 3C2, must be equal to negative 1. The second component is minus C1 plus 2C2 plus C3. It must be equal to positive 1. The third component, the last one, is going to be 0 plus C1 plus 4 C3. Yes, ma'am.
That's where you went wrong.
You're at the very beginning. Where, ma'am?
Well, it's not C1, it's C2. C2 plus
Which component? Is it the first, second, or third component?
the third one.
The third component.
Yeah. It's supposed to be 0 plus C2 plus 4C3 is equals to 19.
Oh, shucks. Oh, shucks. You.
Yeah, the sharks will kill you.
Bad will.
Yo. Okay, I see. Thank you very much, man. Yo, I didn't see that. So it's supposed to be 0 plus C2 plus 4C3.
Yes.
Say,
Hello?
Thank you very much.
can they help a poor brother out here?
Yeah, before we come to the poor brother, therefore, please thank that sister who helped you to identify where you made a mistake.
Was it Nokwazi?
Nomthandazo.
Nomthandazo? Thank you very much, ma'am. I really appreciate it. Nomthandazo. Thank you.
Thank you, therefore. Thank you, Nomthandazo. Poor brother, we are now in your capable hands.
You know, sir, I'll be honest, and I just wrote the equation as it is. And then I stopped there, took pictures, I sent what I wrote. 19, 20, 21, I didn't do anything. So, sir, I see there's some sort of expansion here. Okay.
Lerato,
Uh-huh.
do you want us to do our usual dance?
Yes, because it's
Let's do. No, it's cool. Let's do our dance. So please open my work and go to number 19, please.
Okay, let me go.
It's time for Lerato now to do what we do best.
Okay.
Which is teach each other.
Yes, now where should I go? To number 19, eh?
Please, good sir.
This is 18, 19. It starts here.
Yes, please. Okay, so Lerato, firstly, with these kind of situations, I did them a couple of ways, and I found the two easiest ways to do them. And I know at 19 I double checked it because I did it both ways. You can either use Cramer's rule or you can use a matrix and try get a triangular matrix, but I'll explain. So basically, Aniti, as you know, they asked us to get the scalar quantities, right? That will help us make this equation be equal to what we have on the right, correct? So we're looking for C1, C2, and C3.
Okay.
Cool. And then what we do is we all start everything the same. I distributed the C's into the brackets, and then you see it's what I got there. And then once I had that, I basically put everything in the form of a matrix. So please scroll up.
Up.
Yes, thank you. Down, sorry, down. Oh my gosh, I always get this wrong. Yes, so you can stop there for now. So as you can see, all of this you know from here, where literally I put everything in the form of equations, and then from the equations, I'm going to form a matrix. So please scroll again. Yes. Do you mind zooming out a little bit, please, so we can see the full page? Oh, nope, out, other way. Please. Yes, thank you, sir. So thank you, sir. So you see how I got to the point where I wrote, you see where when I wrote solve via Gaussian elimination or Cramer's elimination, you see how I got there, right? I basically took the equations at the top and I formed a matrix with them, right?
So use the unit vector thing.
What do you mean by that? I don't follow.
Like the coefficient matrix.
Yeah, the coefficients, yes. I used the coefficients and I formed a matrix with them. Yes. That's what I did. And then, like I said, I like this method because it's quick. Then after I form the matrix, what I said is because I've got 3 unknowns, I'm going to use process of elimination via the matrix. And then I literally formed an a lower triangular matrix, as you can see, via elimination. And then in the end, you literally have your value for C. You work backwards because you're gonna get your value for C3. In this case, C3, as you can see, 19 C3 is 95. And then when you work it out, C3 equals to 5. Now you've got that value, then you can plug it into the equation at the top. And then you solve that, then you plug it into equation at the top of that one, and then that's how you get your C's. I think this is the easier way. Or if you don't want to do this, once you get to the step where you've got the matrix, like the one I have there under the solve what, you can use Cramer's rule, and you'll still get your C's to be the same. I think this is an easier way. Does it make sense?
Because like the equations, there are 3 of them, so it's much easier.
Yeah. So even if you had 4, it still works out easier this way, I think.
than Cramer's rule. Yes.
Cramer's rule is longer. I agree. So what I found when I was doing it, is it actually hit me so well. Cramer's rule is longer, but it's easier to do. For me anyway. This is shorter, but it needed me to do a bit of mental deduction, quite a bit. So yeah, I think in the exam, if I had to do this thing, I'd lean towards Cramer's rule because I can do it without even thinking. And then
like Theo, like how did you know C1 is a constant?
Eh?
C1, is it not a variable?
No, only they say good. Only C1 is a scalar quantity.
It's a scalar.
And scalar quantities are constants.
Okay.
Yeah.
Constant, because I thought C1 is a variable.
It's a scalar quantity, and scalar quantities are constants, right? Because you multiply them into either a matrix or a vector or whatever. Now it makes sense, right?
Makes sense.
I'm glad. We did it again, brother. We did it again. Thank you, sir.
Thank you, brothers. Thank you, brothers, for helping.
Can I also thank Theo, sir? Thank you very much, sir. I didn't know that you can solve this system using matrices.
Yeah.
And the way I was solving it, it was very complicated. And now I found a much easier method.
It's easier this way, man. Yeah. And again, I'm glad now that we're speaking about it. When I did my workings using Cramer's, I tore them up because I decided I'm just going to submit this. But I would have also submitted that, and then we could have compared this and Cramer's. But yeah, the answer is always the same in the end.
Thank you, brothers. That's what we are here for, to learn from each other. Yes, my sister.
May you please scroll up? It's Wayne. May you please scroll up a bit from where he started working out this?
Here.
Okay, I see. Thank you. We can move forward. Thank you, sir.
Forward.
Yes, we can go to the next question.
Oh, okay. Thank you. Now,
can we just confirm the answer for number 19? What are the correct answers?
Oh, yes. C1 is 2, C2 is -1, and C3 is 5.
I agree.
2, -1. You said 2, -1, and 5.
Yes.
Thank you.
Yes, sir.
Do you all agree?
Yes, sir.
Yes, sir.
Thank you. Now we are moving to number 20. Who should I go to? Anyone who volunteers?
Tando.
Tando, my sister, you are very quiet tonight. What's wrong? Is your stomach full now?
Yes, sir. I was listening.
Now let me go to you. Tando. Yes, Tando. Now we are going to number 20. I hope we don't find fingers, but we do find number 20. Yes, number 20. Okay. According to Tando, in number 20, C1 is 6. C2 is 2. C3 is -4. Do we all agree or do we all disagree?
I agree.
I agree.
Don't know.
Who doesn't know?
I say I got stuck here.
Is it Nomtandas?
Yes, I didn't even get the answer. Yeah.
Okay. Where did you get stuck, my sister?
Say I only did a few steps and I left. I didn't even know how to proceed.
Oh, you left. Where did you go to? Where did you leave for? You say you did a few steps, then you left. Where did you leave for?
For
The
question
other
21.
colleagues, what did you find?
This is what Tando found. Okay, first of all, let me rephrase my statements. Anyone who agrees with Tando's answers for C1, C2, and C3?
Yeah,
Therefore
Chris.
agrees.
Yeah, Sean agrees.
I agree.
Okay. My sister who left, it looks like it. Hey, Lerado's quiet. Lerado. Hey, looks like Lerado left. Tando.
Hello, sir.
Is Lerado eating?
Yeah, I think he's dining now. Yeah.
No,
No, he didn't skip country, still here.
Where are you, Lerato?
no,
Lerado.
sir, like it was on
Lerado.
mute.
You are on mute.
I was muting you.
You are muting me.
I was muting the call. I was like,
Okay, brother. This is what members are agreeing on. Do you also agree or do you disagree? For number 20, I mean. Yes. This is what Tando got.
so I won't lie, sir. I got to those equations,
Uh-huh.
but I could not solve them further because number 19, going forward, I had no idea where to start. So I'll agree with the
Okay.
answers.
That means it's Lerato. There is someone who left. Who's that lady who left? The lady who
Sharon.
left.
It's Nomtandazo.
No, I'm here.
No, the lady who left the question.
Nomtandazo, sir.
Oh, Nomtandazo. Thank you, my sister. Lerado and Nomtandazo. I'm going to request my sister Tando to take you through how she worked out this until you master it. Okay? Please listen attentively. Please listen attentively. Yes, Nomtandazo?
I have seen my mistake.
Are you sure?
Yes.
You don't need any help.
No. I had a different question. I don't even know what number is this. So yeah, that's where I went wrong.
Lerado? Okay, thank you, Nomtandazo. Lerado?
So I can see what she did. She used the elimination method of simultaneous equations.
Or you don't need me to ask her to explain?
No, it's fine. If she wants, she can break a little and use substitution. Yeah. Like people who break, they use substitution method.
No.
for simultaneous
Hang on, let's not go there, please. Let's not go there. My question to you is simple. Should I ask Tando to explain?
No, sir.
Yes or no?
No, sir. I can see how she got to that.
Okay. Thank you, everybody. Thank you, Tando. Now, the last one. Where should I go for number 21?
I would love to redeem myself from number 19.
Oh,
and myself.
Oh yeah. And who's self now? Who's myself?
It's
Wait,
T4.
say, I did not
T4
do
and
that
Wendy.
one.
T4 and
yeah.
Wendy.
Yes.
Okay. Sibusiso. Sibusiso.
Hey, he skipped town.
Sibusiso. How can this man skip town? But was he here? I didn't even hear his way today.
Today, I don't think he came because, like, I'm not sure.
Okay, let's go to his work for number 21. Yeah, he even wrote his name as if he doesn't want to. Number 19. No, this man was tired. He didn't attempt number 21. Okay, now I'll just go randomly. Let me go to Nokwazi.
Yes, that one page.
Okay. Let me go. Nomtandazo.
No, sir. Don't go to me.
Nomtandazo, are you sure that we shouldn't
Yeah,
verify?
please don't.
Oh, okay. Now, Nomtandazo, whose work should we go and check? If you don't want us to check yours. Sharon?
T4.
No, sir. Don't pick mine, please.
T4.
Okay. Tando? My Tando.
Hello, sir.
Can we check your number 21?
Yes, sir.
Thank you, my sister. Number 21. This is how Tando worked it out. Huh. This is interesting. Okay, this is Tando. Who else worked out number 21?
Theo.
Let me go to Theo.
Whoa, okay. Whoa. Wow, thanks.
Now,
okay.
Okay, all of us, do you see this screen? Do you see what our sister is saying? She says the scalars do not exist because these equations cannot be solved simultaneously.
Why does she say that? If I may ask you.
She gave a
I
reason.
don't know. Hey, Tando. Tando.
Hello, sir.
Hi. Please talk to us. We just don't want to focus on this last line that you wrote. Please. Here we see that at the end you have got, okay, let me not talk over what you wrote. Please take us through what you wrote up to that statement, and then maybe we can be able to salvage something from what you wrote.
Okay, so to me it was easy because they said sure that they do not exist scalars C1, C2, and C3. So such that C1 is that one plus C2 plus C3. So what I did, I came up with 3 equations. Then I named them 1, 2, 3. Then I tried to solve them simultaneously. I first eliminated C2, whereby my first equation was 6C1 plus 16C3 is equal to 12. So I went further. You can scroll down. I went further. I eliminated C1. Then I got 3C2 minus 3C3, which is equal to -6. So I didn't bother to go further because when I'm checking those two equations that I came up with, you see it's 6C1 plus 16C3. Then the other one also is 3C2 minus 3C3. So I can't eliminate, or I can't find the value of 3C2 there.
Okay, here is my question. Here is my question to you, my sister.
Yes, sir.
Is this statement that you wrote at the end based on this last step of 3C2 minus 3C3 equals to -6?
Yeah, and the other one, that one for elimination of C2, which is 6C1 plus 16C3. So I can't solve those two equations simultaneously because there is 6C1. On the second one, there is no C1. And even if I eliminate using -3C3, it's impossible. So I didn't go further, but I just checked with two scalars. Then I didn't bother to find the third one because it shows that the scalars do not exist. Because I can't simplify it further. I can't solve those equations.
I agree with her.
I also agree.
I agree as well.
I hear you agree, but before I can fall into your trap, here is my question. You see from here, from this 3C2 minus 3C3 equals to -6.
Yes.
I'm not saying Tandodi didn't try this. I'm just throwing it back to you. Let's say we write 3C2 equals to -6 plus 3C3.
Correct.
And then at the end we divide by that 3. Then we'll have C2 equals to something on that other side. And then we'll also be having a constant. Okay, that means we'll be having -2 plus C3.
Yes, sir.
Do you get me?
Yes, and then
yes, sir, we understand.
Now, if we then have C2 in terms of that constant plus C3, and then go back, is there no way that we can be able to find one of these unknowns?
Say I did it in
I
that
think
way
there's no
using
way,
substitution. And at the end, what's gonna happen is the constants, they cancel out on themselves in the equation. You will be left with some constant, which is a number that we know, equal to that very same constant. So what happens is at the end, you find an equation that is balanced, but it does not have the variables that we want, or rather the constants that we want.
Oh, all right.
I don't know if I'm making sense.
You are making sense. So then, is that the reason then you people then agree with this statement?
Yes,
that
sir.
All right.
Yes, sir.
Now,
I think, sir, that the easier way, it's that of Theo using Cramer's rule, because the determinant of A, you get zeros. When you divide by 0, it does not exist. So,
Chef's kiss. Yes.
Away.
Chef's kiss.
Let's see how Theo worked out this one.
Oh, no, I didn't use Cramer's rule, but I agree.
Let's go to Theo and look at number 21. Lerato, how did you work it out, my brother?
Say.
Theo also says These scalars do not exist. Lerado, what were you saying?
Like, go to the original question.
Original
top
question.
there. Yes, on top.
Yes. Yes.
I don't know if it's me, but C1 and C2, they look like multiples of each other, the components in there. I don't know. Yeah, so I agree there's no scalar here.
Oh, okay. Somehow
It's either
then. Yes.
No it's either it's no solution or infinitely many solutions between those two.
Now, what is this telling us? Do you see where my mouse is moving?
Yes.
Magic numbers right there at the bottom.
Do you see this?
Yes.
What do we say when we are facing this situation?
No solution.
The system has no solutions.
Chef's
Thank
kiss.
you.
Chef's kiss.
Thank you.
What do you mean?
Huh?
No, like the system has no solutions because 0 cannot be equal to 12.
Yes.
Mm-hmm.
See,
we talked about this long ago.
I agree, say a long time ago. But say if you get a matrix and then there's a row of zeros and then it says it's equal to 12x.
Row of zeros,
you don't know
then
the value
on the other side is 12x.
Yes, they are not telling us any conditions for x. What do we do?
In that case, you will say that if x is 0, then you're gonna have 0 is equals to 0, which is gonna become infinitely many solutions. But if x is any number that is a real number, then that system will not have solutions because you will now be having 0 equal to some real number, which does not exist.
Okay.
So that system will only exist or have solutions when x is 0.
Yeah, that's fine.
All right. Let me take this opportunity to thank you all for having attempted all these questions that I requested you to work on. Now, let's start here. Norm, dot product, and distance in an tuple. All right. The length, norm, or magnitude of a vector is denoted by, do you see this sign? Do you see where my mouse is? Do you see equation 1?
Yes, sir. Yes, sir.
Yes. In this case, we have got the vector v, which has got two components, which is v1 and v2. How do we get the length, which we usually refer to magnitude or norm? We take the square root, and then we square the vector, the components of the vector, and then we put them inside the square root side. We square the components of a vector, then we take the square of them. Is that clear?
Yes, sir.
Thank you. In this case, vector v had three components, v1 and v2. This is how then its length or magnitude will be calculated. Now, if it is got three vectors, this is how the length, norm, or magnitude of the vector will be calculated. If v is equals to, if v is having these components, v1 up to vn, the norm or the length of the magnitude or the magnitude will be calculated in this way. Still with me?
We are with you, sir.
Thank you. Or are others already sleeping or what? Now
With you, sir.
calculating. Sorry? Are they
I was
sleeping?
saying we are with you, sir.
All right.
We
Now,
are still in the
example
class.
one. Vector what? Someone is talking? Is it Vincent?
Yes, I said we are still in the class.
Oh, okay. Thank you. Now, in this example, vector V has got 3 components, -3, 2, 1. And then to find the norm for vector V, we take the square root and then we square. We take the sum of the squares of the components of V. Are we together here? For
Together,
vector
sir.
V,
Yes, yes.
vector V, which has got 4 components, which are 2, -1, 3, and -5. The length or the norm is the square root of the sum of the squares of the components of vector V, which gives 39. Can we continue?
Mhm.
Thank you. Theorem 3.2.1. If V is a vector in n tuple, and if K is any scalar, then the length of vector V is positive. That is what number A is saying. The length of vector V is 0 if and only if V is 0, if vector V is 0. And then the length of vector V times a scalar is equals to scalar times the length of vector V. Are we clear?
Yes, sir.
So on that one, sir, on number C, if
Sorry.
K is negative, we will take the absolute value of it.
And then at the end, what is the absolute value of a negative number?
It's a positive number.
Thank you, my brother.
Okay.
Now, let's talk about a unit vector.
Sorry.
A
Sorry,
vector,
sir.
yes,
Sorry, sir.
yes,
Sorry, sir.
yes, Vincent.
Sorry, sir. Vincent. Sorry.
Go ahead, Vincent.
What's the reason, like, if I may ask, what's the reason of scaling? What is scalar like it does, like on a vector, like if I may ask?
Please come back again with a question.
Yeah, my question is, what is scalar does on a vector, if I may ask? What a scalar does, like on a vector, if I like, I
On a
ask.
vector, okay. It increases the size, it increases the magnitude
Okay,
of the vector.
you said like the length. You said the length. Okay.
It increases the magnitude of the vector.
Oh, okay.
It
And then
increases or decreases. If it
okay,
is a fraction, if it is a fraction, it will decrease. But if it is just a number, it will increase the magnitude of that vector.
what about direction?
Here, we are not told about that. In this case, in this type of examples, where we are not told about directions, we know that a vector has got magnitude and direction.
Okay. Because
Here, the norm is only the magnitude, but the question here is how to calculate the magnitude, not the direction.
Oh, okay. Oh, no.
Were you here? Were you with us yesterday?
Yeah, I came late, like yesterday.
Oh, okay. Everybody is clear here on this theorem, no?
We are together, sir.
Thank you. Now let's talk about a unit vector. A vector of norm 1 is called a unit vector. Okay. Now, how is that? Let's look at equation 4. what do we do? In order, what are these people saying here? Okay, to get unit vector, we'll take unit vector, which is denoted by U. We'll take the given vector, which is V, and then divide it by what? By its magnitude. Is number 4 making sense?
Yes, sir. Makes perfect sense.
You take that vector, then you divide it by its magnitude in order to get a unit vector. Now, here they are normalizing or getting a unit vector. Find the unit vector U that has the same direction as V. So what do? You get the norm of vector V as they've done previously. All the components squared, then you take their sum, then you take the square root. Then from there, you
So
use this
can I-
formula. Yes.
Every time when they say normalize a vector, they mean that we must find the norm
The unit vector.
The unit vector.
or the unit vector, I mean.
Unit vector, yes.
Oh, okay. Okay, thank you, sir.
When they say find the unit vector, you know that it is that vector divided by its magnitude.
Oh, by the way, it's a vector. Sorry, doctor. By the way, it's a vector with the length of 1, and then in the same direction with the original vector.
A vector of norm 1 is called a unit vector. Vector of norm 1. What is a norm? Norm is the magnitude, is the length. Now you are bringing me up here. Such vectors are useful for specifying a direction when length is not relevant to the problem at hand. You can obtain a unit vector in a desired direction by choosing any non-zero vector v in that direction and multiplying v by the reciprocal of its length. For example, if v is a vector of length 2 in R2 or R3, then half v is a unit vector in the same direction as v. Is this paragraph making sense?
Yeah, bro.
Unit vector, you just take a
Yes,
vector,
sir.
you divide by its length or magnitude, and that's it. As they did in this case. Find the unit vector u, you take this vector, you find its length or magnitude. From there, you see that its length is 3. Remember, this formula, it says 1 over the length multiplied by the vector is 1. The length is 3 multiplied by the vector v. Now applying 1 over 3 into the brackets and having this. As a check, you may want to confirm that this unit vector is equals to 1.
It is, sir.
Is it 1?
Yes.
Yeah, it is. It's like it 2 squared, and then plus 2 squared, which is 4 plus 1, 9, and then square root of 9 is 3. 3 over 3 is 1. Square root of 1 is 1. Then that's the length. That's 1.
Okay, thank you.
Exactly. Yes.
Linear combination of unit vectors. What are they saying here? Okay. This one, you can just do it on your own. I'm interested in the distance here. If P1 and P2 are points in R2 and R3, then the length of the vector from P1 to P2 is equals to the distance between the 2 points. Specifically, if P1 has got these coordinates, P2, these coordinates, are points in R to the 2, then formula 4 implies that the distance from P1 to P2 is given by the square root of x2 minus x1 all squared plus y2 minus y1 all squared, all inside the square root. Yesterday, we calculated, what did we calculate yesterday? From P1 to P2, from point P1, which had the coordinates x1, y1 up to x2, y2. What did we calculate?
The direction vector.
Now here they are talking about what? The distance, okay?
Distance.
Yes. Now this is how we calculate the distance. The formula, here it is. And now they are repeating it here in the definition. They are saying if you see having these components U1 up to UN and V has got these components V1 to Vn and are points in R to the N, then we denote the distance between U and V by D. Distance between U and V, D into
Yes,
U
sir.
and V, which is equals to the length of the difference between U and V, which is equals to U1 minus V1 all squared plus U2 minus V2 all squared plus up to UN minus Vn all squared, all inside the square root sign. Is this making sense?
Yes, sir.
Understood, sir.
Let's look at example 4. If U is given by 1, 3, minus 2 and 7, V is equals to 0, 7, 2, 2, then the distance between U and V is the square root of 1 minus 0, 3 minus 7, minus 2, minus 2. Oh, there is a plus in between, and all these differences are squared. Plus 7 minus 2 all squared inside the square root sign. It's giving us the square root of 58. Do you see the difference between the distance and then what we calculated yesterday?
Yes, sir.
Yes, sir, we see it.
Are you sure?
Yes, sir.
The most important thing is to be able to notice the pattern between what we did yesterday and then what we are talking about here now. Thank you. Now, let's look at this definition. If U and V are non-zero vectors in R2 or R3, and if theta is the angle between vectors U and V, then the dot product, also called the Euclidean inner product of U and V, is denoted by U dot V and is defined by U dot V is equals to the length of vector V, the length of vector U, multiplied by the length of vector V, multiplied by cos theta. Then, in simple terms, this is how it can be written. The sign of the dot product reveals information about the angle theta that we can obtain by rewriting formula 12, this one, as cos theta equals to the dot product of U and V over the product of the length of V and the length of U. What is important for me is this. They're saying, since theta is between 0 and pi, it follows from formula 13 and properties of the cosine function studied in trigonometry that theta is acute if the dot product is greater than 0. The dot product, this, what is in the numerator, is greater than 0. Theta is obtuse if the dot product is less than 0, meaning negative. Theta is equals to pi over 2 if the dot product is 0. Very important information. Do you see what I've highlighted?
Yes, sir.
Yes, sir.
Thank you. Now, let's come here. They say, find the dot product of the vectors shown in this figure 3.2.5. The length of vector u, we are told, is 1, and the length of vector v is 8. And the cosine of the angle between them is 45 degrees. And then we know, remember, we did talk about the special angles, eh?
Not yet.
Yes, sir.
Vincent.
Sorry.
I don't know whether it's in this module or 1512.
Maybe I was not in the class, but like we never talked about them like here in the class, but I don't have any problem with the special angle.
Those special angles are 0, 30, 45, 60, 90, what? There are multiples including 180, and there are multiples. Those are the special angles that we are talking about. Now, this is what they are saying. U dot V is equals to the length of vector U, which is 1, multiplied by the length of vector V, which we were told that it is square root of 8 or 2 root 2. Okay. Now, when we multiply all this, what do we get? 1 times 2 root 2 times 1 over the square root of 2 is 2.
The root 2's will cancel each other, so you have 1 times 2 times 1, which is 2.
Which is 2. Thank you. The most important thing for me, for you to know, is to be able to apply this formula to calculate the angle between two vectors using this formula. And again, to can be able to interpret this when the dot product is 0, even when the dot product is less than 0, even when theta is equals to pi, when the dot product is equals to 0, to can be able to tell that theta is 90 degrees. That is important. That is what is important for me. Okay, how do we calculate the dot product? This is how we calculate the dot product. If vector u has got the components u1, u2, u3, v has got the components v1, v2, v3, the dot product, we multiply the corresponding entries, but we are adding. Okay. This is in 3 space. In 2 space, this is how we calculate them. All right. Thanks.
Sir, go above.
This, sorry?
Oh, now
Above.
I see it. Now I can see that.
Okay. So this definition just They are just explaining what they've been doing over here, what we just talked about, the dot product. This is how we calculate the dot product. Example 6, vector U is given by this, has got these components, 1, 3, 5, 7. Vector V, minus 3, minus 4, 1, and 0. The dot product for these two. So what are they saying here? The component forms of the vectors are, which ones? Oh, okay. Let's focus on this one. Vector U has got these components, 0, 0, 1, V, 0, 2, 2. The dot product, we multiply the corresponding entries, but we add. It will be 0 times 0 plus 0 times 2 plus 1 times 2, end up having 2. Do we agree?
Yes, agreed, sir.
Thank you. Now, for this one, number B, the dot product, 1 times minus 3 plus 3 times minus 4 plus 5 times 1 plus 7 times 0 gives minus 4. Still together?
Yes, sir.
Together, sir.
Thanks. Now, I don't want to bother you with this. The length, we all know. We talked about the length already. We have been talking about this throughout. I don't think you'll have a problem with this theorem 3.2.2. Even theorem 3.2.3. This is what we have been talking about. Calculating the dot product of U minus 2V times 3U plus 4V. How do we do that? We take U, we multiply by 3U plus 4. Okay? Then we take minus 2V, we multiply it by 3U plus 4. Take U, you apply it every term in here. Are we together?
We are together, sir.
You take minus 2V, you apply it to every term in there. That's how it's done.
So, sir, we do this when they say maybe express your answer in norms or.
You'll be calculating the dot product. They will tell you. Okay, don't panic. Don't panic. Please keep cool. You will see. You will soon see what these people will be asking you.
No problem, sir.
Now, the next thing that we need to talk about is the Cauchy-Schwarz inequality. Cauchy-Schwarz inequality, do you see equation number 21?
Yes, sir.
Okay. Do you see equation number 20? Okay, let me just read this to you. Our next objective is to extend to R to the power n, the notion of angle between non-zero vectors U and V. We will do this by starting with the formula. Remember where this formula is coming from? From the top.
Yes, sir.
This formula is coming, it's the same as this one. It's the same as this one. Are you with me?
You mean like that Cauchy what is the same as like the dot product that you said?
It has been rearranged.
Or the Cauchy.
Before the inequality.
The name. Okay, if I may ask
Yeah. They took the cos to the other side. They are looking for an angle. That is why I'm saying it has been rearranged. It is coming from there. Because from up there, you have got cos theta equals to that. But in here, cos is on the other side.
I mean this Cauchy what? This, and then am I wrong if I say this Quachi, how this Quachi what is related like to a squeeze theorem, like?
To a squeeze theorem,
Yeah.
which we dealt with in MAT 1512.
Yeah, I think so, yeah. Somewhere there, like, yeah. Like let's say for an example, this Quachi, like they are telling like Uri, I'm just like, you correct me if I'm wrong. They are just telling Uri like, if I take like the cosine and then the period will oscillate between -1 and 1. Like it depending Uri, it start from like above, and then if it start from above, I know that that's gonna be like a cosine, and then if it start below, then I know not a cosine, it's either be a sine.
Vincent,
I think
the rule from theta is equal to -1, it's obtuse. Theta, when it's equal to 0, when theta is 90 degrees, when theta is 0, it's theta over 2. When theta is less than 1, it's 1. It comes
Yeah,
from that.
that's what I was trying to explain. Like 1, and then above, and then that's an acute, and then 1 below, and then it's like a 180, and then when it comes like so like it determines like the quadrants like this. Quashi what like.
Oh, okay. I'm not sure. You'll ask.
I just don't want to bring the relationship between Cauchy-Schwarz inequality and the squeeze theorem here.
Okay.
I don't want to confuse you and the others. But here, Cauchy-Schwarz inequality is saying that the dot product of two vectors divided by the length, divided by the product of the two vectors lies between -1 and less than 1. Greater than -1, and greater than or equals to -1, and less than or equals to 1. Now, here is this Cauchy-Schwarz inequality. If vector u has got these components, v are vectors in R to the n, then the dot product, which is less than or equals to the product of the length of vector u and vector v, or in terms of the components, this is how it is. Don't panic. The most important thing is to be able to calculate it, to be able to use this formula. In the next few minutes, you will see it, how we calculate it. This theorem, 3.2.5, it is saying the length of two vectors u and v is less than or equals to the length of vector u plus the length of vector v. The distance between vector u and vector v is less than or equals to the distance between vector u and vector w plus the distance between vector w and vector v. Triangle inequality for distances. That's number B. Number A, triangle inequality for vectors. I hope you know the difference. You are lucky these days you are not required to prove in the exam. Parallelogram. Theorem 3.2.6. Parallelogram equation for vectors. If u and v are vectors in R to the n, then the norm squared of the sum of these two vectors, u and v, plus the difference of these two vectors squared is equals to 2 times the square of this vector u of the norm of this vector u plus the square of the norm of vector v. Don't worry, you will understand how they are applied soon. Theorem 3.2. Theorem 3.2.7. 7. Theorem 3.2.7. If vector u and vector v are vectors in R to the n with a Euclidean inner product, then the dot product of u and v equals to a quarter of the square of the sum of the two vectors minus a quarter of the difference of the square of these two vectors. You will see how to apply them soon. I don't want to bore you with this. And that's my story. For now, please go and digest what we talked about in this section. Then tomorrow, we'll start with the exercises related to this section. Is that okay?
It's fine.
No problems.
I'm not giving you any homework. Tomorrow, if anything is not making sense, now we talked about it. Go digest what we talked about. Tomorrow, if there are any questions, then we'll start with those questions before we tackle the questions. Are we in agreement?
Yes.
Yes,
Understood, sir.
Sir, can I say something?
Yes, always, ma'am. You can always say something.
Okay.
You can always say some things. You don't say something. You can always say some things.
Okay, sir. Sir, Mike, I don't know if it's a question or what. The system that we are.
Who's talking? Who's talking?
Yeah.
Yes, Kay, I'm listening, my sister.
Yes, so the new system that we are using now of you giving us work to do and we submit answers and we discuss. So if you were not in the lesson the previous day, how is it that you can catch up? Because I was not in the lesson yesterday and today I was just a spectator. So basically I would say the whole 2 hours I did nothing, I was just watching. So I don't know how can you find a way for you guys to accommodate someone who was not in the previous lesson? Because the way we do things, if you are not in the previous lesson, there's no way that you can catch up or engage in the lesson.
Let me not respond to this. Let me ask your other family members to respond to you. I'm keeping quiet. Members, please talk to Gil.
I would like to say something. Hello?
Yes, I'm keeping quiet. Please talk to Gia.
Okay, so Gia, my thing is, and I like your question because it's going to happen a lot where people come to the lesson and they weren't there yesterday. I think that path of least resistance for everybody is if you were not there yesterday, let people know that you weren't there, and then they can give a brief overview of what we're about to do. And then the nice thing is with this is as we do the sums, you can follow because they're generally very straightforward. Because in this case, we're calculating vectors. So even if you weren't there, you can follow because I also like how you said you basically did nothing for 2 hours. Whereas my thing is basically you could have learned in the 2 hours where when we were all questioning everything we did, you could have looked at the sum and been like, oh, okay, cool. So this is what they're doing. And you could have also done it with it, even if it was mentally. I don't think you did nothing. I think you did learn something. The only thing that I guess we should have done is we should have asked if there was anybody who wasn't there yesterday that might need a quick explanation. That's what I think we should have done. And what I think you should have done is you should have also raised the point that you weren't there yesterday. So you'd like a quick rundown. We could have given you a rundown in 10 minutes and then we could have all continued on the same pace together. That's my suggestion.
Thank you, Theo.
Commentary, everybody else?
Applause for that.
Yes.
I second you, my king. I second you.
Yeah, because again, just to add to that, my thing is always going to be, you know, the whole thing where they say you can't leave your fate in other people's hands. I feel like if as a person you weren't there, you must let them know that, guys, I'm not where you are. So please get me up to speed so that when you guys start moving, we can all be in the same train and on the same carriage. Because like what happened today is, and I'm sad it happened. I apologize on all of our behalves. It literally feels like we're all running a different race. Whereas the aim of the workshop is for all of us to always be on the same page. So going forward, when we start the lesson, we will all ask if there's anybody who wasn't there. And then should we not do that, then we ask that if you weren't there, also take initiative and tell people that you weren't there yesterday. What did you guys do? Please bring me up to speed. And then we all just move from there. That's all. That's my 2 cents anyway.
And if they have WhatsApp, they must as well join WhatsApp because Lerato always send the homework and
Oh,
stuff.
yeah, he does. Yeah, he does. Because I've seen, I'm glad you said that, because I've seen on the WhatsApp group, it tends to happen on the WhatsApp group that when people didn't attend, they will ask, what did you guys do? Then Lerato being Lerato, he will let you know what we did, and he will send you screenshots of all the homework that we have so that by the time you come to class, you are literally where we are. So yeah, the WhatsApp group is a good idea as well.
Thank you, Gia. I hope you have now got clarity in terms of how we handle this kind of a situation that you are finding yourself in. Gia.
Hello, sir. I didn't get what you just said. I didn't get what you just said.
Please, members, please repeat to Gia what you just said.
No, I heard what you said. I didn't hear your comment, your last comment.
My comment.
Yes.
Let me reserve my comment. But did you hear what they said?
Yes, I don't think I'm in the same WhatsApp group. So can I be added to the chat?
Members, please help out here.
Like
I'm
the
keeping quiet.
numbers, can she send them to the chat?
Yeah, write the numbers on the chat. Lerato will take your numbers and they will add you on the group.
Okay, thank you.
Is it Gabby?
Can I also be added? I'll send my numbers on the group on the what you call.
Thank you once again.
Thank you guys.
Like on chat, you can ask anyone for what we're doing today. They will help you. They are helpful there.
Oh, another suggestion, because I don't know how I forgot to say this. So, Kia, seeing that you say you weren't here yesterday and you don't know what we did, what you should do, and again, this goes for all of us, should you miss a lesson and know that you're going to want to attend the next day, watch the recording. Because the recording is basically what you missed. So that once you've watched the recording, when the new class starts, you are up to speed. Assuming you have time anyway. But I think a good idea is if you can, and if you have the time, watch the recording from the previous day.
Any other question? Gia, have you been answered?
Yes, thank you, sir.
I just decided to keep quiet because, you know, here This is not a one-man show. This is our show, okay? We are no longer in that other type of era. We are in another era, in a democratic era, where we talk. We just don't tell people to do as we please. No, people discuss and then come up with a solution among themselves. Okay, that's how we operate. I mean, that's how we have been operating all along. I can't give you the solutions because I might give you the solutions that are not applicable to you or that are not favorable to you. So you members need to come up with the solutions that will be favorable to all of you. That's how I tend to operate. Or am I not being fair? Or should I be holding a stick to be saying, hey, you didn't come today. Come, here is a cane. Here, should we go back there?
No, sir.
So I don't operate like that. Any question? In the absence of any question, then let's just call it a night.